Hello, and welcome to another episode of Hi, I'm Jason, with Jason Pollock. I am not Jason. Join Jason and Justin back in the green room as they talk with some of their favorite folks from the entertainment industry. And now, the man you haven't been waiting for, Jason Pollock!
Hi, Justin. I get chills every time I see that close-up of my face, and they're not in a good way. Wow. Justin, how have you been?
I've been well, my friend. How about you?
I have a day job, as you know, which is why I cry myself to sleep at night. But it was
There.
wow.
Oh, I thought that was a joke. I didn't know.
No, Justin, this is very serious. We have someone very special waiting backstage right now in the green room, eating our sushi and drinking our Perrier. It's all virtual, of course.
Yes.
But,
yes.
Do you have any housekeeping to do, or is it
Some super quick housekeeping again, because I feel it's been a couple of weeks since we've been on. So,
okay?
Folks that are catching this live, or that might be catching this as a rebroadcast, just want them to know where they can find out all of the things. So let me tell you, folks, real quick. Thank you so much for tuning in to Hi, I'm Jason, with our host Jason Pollock right over there. I'm Justin Gonzalez, the producer and co-host, and again, we want you to enjoy this show, not just this show, but future shows and past shows as well. So how can you do that? Just go over to Facebook, facebook.com/Jason and Justin, and that is where we disseminate all of our information. So please be sure to go to our Facebook page, because that's where we let you know what we are doing, not just virtually speaking, but also live. Jason and I have had in fact, we just did a wonderful live show this past weekend with our dear friend and headliner and inspiration across the world, Miss Julia Scotti. And again, you can find out about all of that sort of information by going to facebook.com/Jason and Justin. If you are interested in looking at some of and enjoying some of our past broadcasts, all you have to do is go to youtube.com and search Hi, I'm Jason, and you'll find all of our shows. If you're looking for some stuff that's maybe not our normally scheduled stuff, of course, we're streaming to Twitch right now on the Drinks, Jokes, and Storytelling page. Hello, everyone over there. But it's not just a place where we do our normally scheduled shows. Sometimes if Jason and I decide that we want to get into some late night shenanigans, or if we have a free afternoon and we want to share something with all of you, you can check that out over on Twitch, twitch.tv/Hi, I'm Jason P, and that P's for podcast. So twitch.tv/Hi, I'm Jason
and
P.
Pollock.
And Pollock, right? I'm now forgetting
Your
all other words that
popsicles were not
begin
up to par
parasol.
tonight.
I don't know. Okay, anyway, if you want to help our show grow and you enjoy what it is that we're doing, or if you want to just maybe get me the P encyclopedia from World Book, so I know next time a word that begins with P, please feel free to visit our digital tip jar, and you can do that by going to Venmo. Venmo, and all you have to do is type in @ Jason-Pollock-2. And again, all of your contributions go right back into our little program here. The different quality streaming platforms that we're able to use, as well as making sure that Jason's Wi-Fi stays on. And Jason, that is all I have for our housekeeping.
Awesome. Justin, I'm so excited to bring out our guest. I watched her TED Talk and I thought, oh my God, this is someone I would love to talk to. I mean, not that our guests haven't been interesting. We've had some very interesting guests. We've had great singers, authors, comedians, actors, photographers.
This is our first academic.
So I read her credentials and I thought, oh my God, I'm not worthy.
I was going to say I'm terrified because, again, like the premise of our show is the fact that we have folks from the entertainment world, but here's this really brilliant person who, again, the work that she does is super inspiring and very, very cool. Really about like learning about what the origins of us are, and I'm not smart enough. I'm not worthy. And here we are. She
seems like a very nice person, though. I think she'll be able to lead us down a good path.
I hope so.
You ready to bring her out? Professor of astrobiology in the University of Hawaii. I'm sorry if I didn't get that right. Karen Meech.
Yeah.
Hey.
Hi.
Thank you so much for being here and taking the time. I know you're overworked right now.
No, it's a pleasure to be here. And you know what? It's the kindergartners that ask the best questions ever because they're not afraid to think outside the box.
That makes a lot of sense.
Okay. I'm going to try to channel my inner kindergartner.
What is one of the best ones they've asked you?
Well, I study comets, and I was talking about comets to young kids, and one kid said, how many comets would it take to fill the oceans? And I thought, oh my God, I have no idea. I should be able to think on my feet, but you've got all these little eyes looking at you, and I said a lot, and then I went back and calculated it, and it depends on the size, but that was a fabulous question that I had never thought of.
That is really outside the box. That's crazy.
Okay,
yeah, you weren't kidding.
So I have to ask, if you had to, so you said you went back to do the calculation. Now, if you were using like an average size comet, now what would an average? Well, that's a better question there. What is the size of an average size comet?
An average size might be a few miles across, and it would take about 1 million to fill the oceans.
Wow.
But there can be some really big comets. We've seen them historically. They've broken into a bunch of pieces, and there it could take a few hundred. So it's not that many. I was surprised.
Wow.
The whole comet and asteroid thing makes me so grateful there are people like you who are watching the skies and keeping us alert. Is there any kind of contingency plan in place to put my neurotic mind at ease?
I don't think so. Well, there's plans, but I don't think we're there yet. What we are doing is, especially in Hawaii, we've got surveys that are looking at the sky every night for potentially hazardous objects that could hit the Earth. But the part that we're not yet fully capable of doing is what to do about it. So it's, kind of halfway there isn't quite good enough if something's coming, but we're moving in that direction.
So those movies, Armageddon, Deep Impact, they were relatively fictional. Obviously, fictional accounts about running a nuclear bomb up there and blowing them up.
Well, nobody wants to go to movies with me anymore because I'll take, especially for those two, I will take a red flashlight and a clipboard. I'm taking notes. I can tell my students what's the good science, the bad science. And they had a lot of good science in there, but one of the bad pieces was trying to take a bomb and blow it up, because then you're just going to have a lot of debris that will certainly hit the Earth, unless it's real far away.
Oh, I didn't even think about it like that. That makes a lot of sense.
You've turned the bullet into buckshot.
What makes me even more concerned what makes me more concerned than asteroids and comets are rogue planets. But how likely is that?
Very, very unlikely. So I think you shouldn't be worried about those.
That's just me watching too many movies.
Yeah.
Okay, that makes a lot of sense. So I gotta ask you that how I watched another show with you where you talked about how you discovered Oumuamua, but I don't. Did you discover that, or were you brought in to? Did you take part in the discovery of this, analyzing what it is?
I did not discover it. We have a Pan-STARRS survey in Hawaii that looks at the sky every night to watch for potentially hazardous objects. And each morning there's a staff member of the telescope that looks at all the moving objects because the automated software doesn't always recognize things because there's defects on the detectors. And he found it on the 17th of October. And then by the 19th, the head of the operation called me at home saying that they thought that this one was actually coming from outside the solar system. And he called me because I've been involved in coordinating a lot of observing programs for space missions. So I have a network of people and I can get things done quickly. And of course, my first thought, I had just gotten back in town from a big conference. I'd been working for months with no vacation. And my first thought was, oh, did it really have to be today? It's my first day off. And then I thought about it for a minute. Well, this is exciting. And so, it's drop everything 24/7, go into the office, sleep in the office, coordinate observers around the world, and get telescopes pointed at this thing. So I led the characterization team that was following it up after its discovery.
That's fascinating. How do you? I'm so naive with this kind of stuff. I just, how could you? The picture you got, I can't even get the words out. Justin, help me. Like when you see something so small going across the sky, how can you tell? I know it's. If you were asking me about comedy or horror films, I can jump right on it. But anything to do with an interstellar object entering the solar system, how could you tell which direction it's coming from or what it's made of?
A bunch of pictures, and you see something moving against the background stars. And if you get 2 points, you could draw a straight line between them, and you know the direction it's going, and you could get the speed if you know the time at which you took it. But 2 points won't give you a curved path. But over a period of a few days, if you get enough measurements, you can start to tell the curvature of its trajectory. Once you get enough data, you can tell the orbit around the sun. And the faster it's moving, the faster you can get this done because it's moving over a longer track. And so really within a few days, at least our team realized that this is coming from outside the solar system. It took a little bit longer for the rest of the world to be certain, but we were certain, so we immediately started to request telescope time.
Wow. Yeah, how do you not lose track of it? I mean, it's so amazing to me, all the little details that go into this. I mean, because I'll look up at the sky and I just see, especially in Maine, you just see every star up there, and you can see little movement. You look down and you look up again and it's gone. Like, how do you not lose track? Do you have a camera on it constantly?
No, but it's moving at a fixed rate along the orbit. So once you have enough positions that you know the orbit, the physics will tell you how its speed changes with distance. So you can make a very good prediction. And we can send spacecraft to the planets. So astronomers and engineers are great at doing this. So that's not a problem.
It just blows my mind. I feel like I'm a little kid again, learning something new. What got you into this field?
Well, if you want to know the truth, it was Star Trek.
Of course it was.
As a kid in second grade, when Star Trek's coming out, I'm telling my parents, this is what I want to do. We would sit in front of the black and white TV on whatever night it was on, and we'd have our TV dinners and watch Star Trek. And Mom and Dad said, you better make sure you like physics before you decide you're going to go into astronomy. And I was a stubborn kid, so I said, I'm going to like physics. I hated it. I absolutely hated physics. But, they should start physics with astronomy, not slabs of wood sliding down frictionless planes. Is that interesting to anybody? Anybody? But
I think that makes a lot of sense. Yeah.
I stuck it out, and yeah, I didn't become an astronaut, but I ended up going into astronomy, which has been a lot of fun.
Good for you. That's fantastic. Yeah, I agree, though. They need to readjust. I hope they've taken lessons on how to adjust teaching that. It's to kids. Like Bill Bryson, are you familiar with him? He was a travel science nonfiction author who writes like textbooks should be written. He writes so you're laughing and you remember at the same time. He uses anecdotes to make you laugh as you're learning, and that's just the way to do it. That's just how you remember. But he wrote a book called A Short History of Nearly Everything, which is like he always wanted to write a science book. It's about from the Big Bang up till where we are now. It's a big book. But he mentioned something in there about if there was life out there in another solar system or somewhere light years away looking down at us, the light they would probably see is a light where Thomas Jefferson was living. And if they wanted to come dressed as us, they'd probably look like Revolutionary War reenactors.
Yeah.
So, I mean, do you agree with that? Do you think I've heard other people talk about life out there? I'm trying to sound smart, and I'm doing such a horrible job of it. I've heard other people talk about this is something I've always been fascinated by, but never discussed with people because I don't sound intelligent when I bring it up. But I've heard other people say the odds of us being here on this planet alone like this is so minute that the odds of somewhere else this exact same thing happening is also highly unlikely. But what have you done a lot of study on life out there on other planets?
Well, my research area is really astrobiology, and of course people joke that so you're researching something that has no subject matter because we haven't found biology elsewhere. And I said, well, it's bigger than that. It's about where could life exist? How do you form a planet that's just right for life? Could we have life elsewhere in the solar system? How did life start on our planet? What sort of conditions can it live in? And the more we learn about what happened on our planet, I think says that it's very likely that we have the same conditions elsewhere. Now, whether it leads to the same type of life, I don't know. We have environments in our solar system that are what we would call habitable, meaning the conditions are suitable that you could take some of our microscopic life and it would survive there. So I think the chances are almost certain there's life elsewhere. Whether or not we will detect it is a little bit harder, because if it's microscopic, you'd have to be able to detect it from afar, and that might be because it changes the gas of its planet's atmosphere. What people would really like to see is technological signatures, UFOs, aliens, but I think that's going to be a lot harder prospect, because if you think over the whole abyss of time on Earth, how long have we had radio or TV? It's been a tiny slice. And of course, that may end soon, who knows? So over the whole eternity of life on Earth, it's only been a really short period where we've had technology, and that may be the case elsewhere. But I think it's out there.
Yeah, well, we do have a question from the audience. What does she think of the Drake equation? I don't know what that is.
Well, it's a really neat equation that Frank Drake wrote in the 1960s, and it was his attempt to estimate the probability that we would find life. And so it's a nice tool. It says, all right, in order to have life, we believe there needs to be a planet. So a planet needs a star. So first of all, how many stars are there? How fast do they form? How many planets are there with each star? And when Drake wrote his equation, we'd never discovered any other planets, but now we know that number. Of those with planets, how many have planets at just the right distance from the star that life could survive, right temperature? We now have a good estimate for that. Of those that are just right, sort of in that Goldilocks zone, how many actually have life on the planet? if there is life, is it intelligent and does it have technology? So he multiplied numbers together and then multiplied by the number of stars to get a probability. But of course, many of those numbers are wild guesses, even still. But even so, with even somewhat pessimistic numbers, it showed that life is probably abundant.
That makes sense. That makes a lot of sense. I mean, if we're here, then yeah, there's got to be something else out there as well. But do you think the variables are much larger than the Drake equation gives us? We know it's a good start. Okay, our watchers are educated.
I'm glad they are, because I'm just stupefied here.
I know. I feel like Chris Farley when he had a Paul McCartney on. Like,
You remember when you played with the Beatles? That was cool. Yeah, no. So, but Polly Chaser is one of our followers on the Drinks, Jokes, and Storytelling channel, and he's also not American, which means he's smarter than your average bear. So
wow.
So here's his follow-up question. Don't you think the variables are much larger than the Drake equation gives us, even though it is a good start?
Well, I think it's a great start, and the variables in the equation, we don't know for sure, but with new observations, new telescopes, we're getting a good handle on many of the variables. I think the really uncertain ones are going to be hard. If you have life on the world, does it develop intelligence? That's going to be a long time before we get a good answer. And then more importantly, or maybe we'll get an answer soon, is if you have technology, how long will that civilization last? Maybe everyone blows themselves up pretty quickly. So this was a great start. I don't think he ever intended it to be, this is the answer, but it was just a way to assess, is it likely or unlikely that there's life elsewhere? So it's a nice tool.
Yeah, I can definitely see that. Of course, I feel like it is likely. When that guy, I forget, it was somebody debating Neil deGrasse Tyson, who was saying what I was talking about earlier, how if the odds that we're here on this planet are so unlikely that the odds that there's anyone else could be more so. But I kind of disagree. I agree with what he said. I think it's, if I understood that correct, there's the odds of there being life out there are, if we're here, then there's got to be somebody else out there. The universe is that big. Like,
another thing that's really interesting, every time we find a new environment on Earth that we can access that may have really extreme conditions. For example, when they open up new mine shafts, deep below the surface of the Earth, and they burrow in and find hot water coming out, they will very often let the scientists go in first and look at the water because it's been untouched, uncontaminated, and there's usually new forms of life in there, new forms of bacteria, microscopic life that we didn't know existed, and it turns out it's really abundant. So everywhere we look on Earth, in the most extreme conditions, we find life. So I think chances are really good that it's going to exist elsewhere. And who knows, it could have started on Mars and delivered life to Earth. So maybe we're Martians, you never know.
absolutely. I mean, the Earth was created from outer space. My God, I mean, it was created from rocks that were floating through space, and yeah. Polly Chaser, ask your question.
I was just gonna say, Polly Chaser is actually the host of the show now.
I know.
Karen.
I've never felt.
So Polly Chaser, I'm gonna let you know, because Polly Chaser came in a little bit later in the show. Our guest today is Dr. Karen Meech. She's a professor at the University of Hawaii, and she is brilliant. And we are not. So Polly Chaser's, he has a few things here. So I'm just going to try to read through them because, again, he is a very good and avid watcher. So do you think evolution is the only way to create complexity throughout the universe, or could there be some other mechanism? Or do you think it is just an intrinsic quality of nature itself? What you said. Where complexity just arises given time. So you like the what that is, hypothesis, because I can't read words. And again, the reason why I'm the co-host, and that's about it. And Moonlights, who's watching on Twitch, also says, I'm learning something new. So
Now we have two people in the audience. That's cool. No, well, that's tons of questions right there.
Well, Polly asked, it was exactly what I was going to ask. I just worded it differently.
Panspermia is the idea that life could have been delivered to Earth from elsewhere. And the reason I brought that up is, we always have meteors hitting Earth all the time. They're just coming into the atmosphere from, it's usually chunks of material that were broken off of asteroids. But if something hits Mars and knocks off a piece of Mars, it could travel through space and land on Earth. And we have meteorites from Mars, and they can often preserve the material on the surface of the planet. So it's easier to get things from Mars to the Earth than the other way around, because Mars is smaller, so it has less gravity. So if life started on both planets, or even if it started on Mars first, it could have more easily dropped onto Earth than the other way around. So that's the idea of panspermia. Maybe life got here not just from Mars, but anywhere, even from outside the solar system. Now, with regard to the other questions, those were a bit more in the realm of philosophical questions. I'm not a biologist, but I think from what I've learned about astrobiology and the evolution of life, it just seems like there are so many steps that are pretty easy to do in space. So I think it's the complexity evolves through a natural process. For example, we know that amino acids are the building blocks of life. They have been discovered in meteorites. They've been discovered in space. So these molecules are easy to make. We have discovered the equivalent of how to make cell walls in space with just fatty molecules that can be created in a space environment and water. So we're getting a lot of the steps towards life, but we don't understand all of the steps. So my personal view is it's a natural process.
Makes sense.
We're just like, yeah, sure. I grabbed a thing and I hit another thing with it, but that sounds really good what you said there, Karen.
I'm sorry if I took the words out of your mouth. I understood that's how you think.
So Polly Chaser wrote, it's just nice, but evolution is really elegant in the way that it explains the rise of complexity. That's not a question; it's a statement. Thanks, Polly Chaser.
Yes.
We're trying to propel this forward here because we're just a couple of clowns.
Because remember, I'm not a biologist; I'm an astronomer. So if we dig too deeply in biology, I'm just going to be making wild guesses.
Oh, you're right. I agree that it seems that the building blocks for life, you mean? He's from Holland, so excuse the typos. For life are abundant throughout space. However, when it comes to complexity, the evidence is underwhelming.
Well, it might be the evidence is underwhelming, but we haven't yet explored everything because we learn about molecules in space with radio telescopes. And I don't remember the current tally, but it must be well over 100. And you can get some fairly complex molecules observed from Earth. But if you really want to look at the complexity that you have in life, that typically is not a remote observation. That would require flying somewhere, getting a piece of material, and analyzing it. So it's not that the evidence is underwhelming because it's not there. It's because we haven't fully explored it.
So that brings me back to Oumuamua. As my wife called it when she said, "What is Oumuamua?" I was like, "That's a song." They named this after a Hawaiian word. Was that right? A Hawaiian word?
Yeah, we asked some Hawaiians to give it a name because it was discovered here. And one of them was a linguist in Hawaiian language, and the other was one of the navigators at the Polynesian Voyaging Society. And they suggested Oumuamua as traveler from afar reaching out towards us. So it had some meaning also.
Okay. So, what is it that separates Oumuamua from from another, just an ordinary comet or asteroid?
In my opinion, not much. It's, what comets are, and this, by the way, is just an artist concept. This is what we think it looked like, but effectively all we saw was a speck of light, like the stars in the background. What comets and asteroids are just sort of the leftover debris from the process of building our planets. It's the stuff that didn't quite make it into a planet, and comets formed cold and they have ice in them, and they got kicked out into the outer part of our solar system where they're stored today in this vast cloud. As you build planets elsewhere, same thing's going to happen, and some of these get kicked completely out of their solar system, and we happen to have one pass through our solar system. So
I get it. I'm sorry. No, I didn't mean to interrupt.
no, that's okay. That's okay.
So that's what separates it. That how you can tell it came from somewhere else, because I know you said because of the difference, but that's what separates it. It's not from Earth. All the other asteroids and comets are pretty much from Earth or one of our planets in our solar system.
They're not from Earth. They're from our solar system.
Okay.
Some of them may have contributed to Earth, but they aren't from Earth.
Got it.
So Polychaser also wanted to ask, so he said, let's stir this up. And he wants to know, what is your opinion of Oumuamua?
Polly, do you know who this is?
Well, what is my opinion? Well, it depends on what you're asking. I think it's a comet. It didn't show a tail, but there's a lot of reasons that it might not have shown a tail. There's one off-the-wall, unsubstantiated hypothesis that maybe it is an alien spacecraft, and I completely disagree with that. This is basically a comet from another star system. And what was neat is we don't yet have the technology to travel quickly to another star system and have a space mission like we do when we go to Mars or Venus or Jupiter. And so the only way we can study other planets is by looking with our telescopes, and that doesn't give us much detail. But here we had a piece of another solar system flying through our solar system nearby that we could study. Even though it was just for a little over a couple weeks, we got to study something from another star system, and we don't know where its home system is. So that's what I think is neat about Oumuamua.
My wife she hates being on camera, but she crawled in the room and gave me a Post-it to ask you a question.
So now we've got 3 people in the audience.
She asked, where is Oumuamua now?
Okay, it's still in our solar system.
Still in our solar system.
It's somewhere between about Uranus and Neptune, about halfway out to Neptune.
So there's no threat. There's no immediate threat to the planet. It's just in a different trajectory altogether.
Yeah, if here's the plane of our solar system, it came in from above our solar system, passed close to the sun, inside the orbit of Mercury, and then went out. And we discovered it on the outbound leg just after 5 days after it made its closest approach to Earth, or a few days after. And most people don't realize just how close it came. It came within 63 Earth-Moon distances, which is really close. But we didn't see it till after it had gone past. And so the discovery of Oumuamua suggests that there's probably a lot of this stuff passing through our solar system that we just never see.
Yeah, we can't grasp how large the universe is. I know that much. I know it's just beyond our realm of thinking.
Even when people think about how fast Oumuamua was moving, they say, you mean it's still in our solar system, but it slows down as it gets farther out, and our solar system is huge. It won't even get to the Oort cloud for about, I've forgotten the number, but maybe till about the year 2500. And the Oort cloud is this vast cloud of comets at the outer edge of our solar system. So the universe is big.
That's an understatement. Yes.
If there, oh, go ahead, Jason. I'm sorry.
No. I was asking if you were going to say something.
I am. I'm going to. What is something as someone in your field, to the average Joe, as you're talking to 2 of them right now, What is you think maybe the most important thing that we could take away from a conversation like this about what it is that you do, and what maybe we could do to learn more about it?
Well, you know what? It's fun. My day-to-day job is I get to think about cool things that would be fun to learn about. I can write a proposal. I can use the world's best telescopes to go make discoveries. So, what a choice is that, to get paid to go discover new things. That's pretty cool. So I may not be able to join the crew of Star Trek, but this is pretty close.
We'll get you an ensign's uniform for sure.
We have a few more comments as well.
So Polly said, but its relative flatness and lack of component also raised some questions, did it not? And he just wanted to say, I think you are mostly correct, though. Thanks for that answer. And then Laura said, will it eventually burn up? So those are a couple of things there.
There were a couple things that were really unusual about Oumuamua. Comets are like dirty snowballs, and they're not a sphere. They're irregular in shape, but they're mostly, say, an axis ratio of 3:1. And so if this mouse here is representative of a comet, they're usually spinning, and so we get the light reflected from the surface. So you get light reflected from the big surface, it's bright. You get light reflected from the small surface, it's faint. And the same thing happened with Oumuamua. It was spinning roughly 3 times a day, but the relative brightness between bright and faint was a factor of 10. So that led us to suggest it was much more elongated. So maybe a ratio of 10:1. Or it could have been more of a image like this, but we're looking at it edge on. So we don't really completely know the shape of Oumuamua, but its reflectivity was dark, just like comets. Although people picture comets with their beautiful tails like Halley's Comet as bright, they aren't. They're almost as dark as charcoal on the surface because it's ice covered with organic compounds. And Oumuamua was dark. So there was nothing unusual about its surface reflectivity, but remember, we only had good observations for 1 week. So we didn't get much data on it, and that's because as it was moving away from us, it was getting faint really quickly. We got this was in October of 2017. We got our very last observations with the Hubble Space Telescope on the 1st of January of 2018. But most all the other data was in a week, 10-day period right after discovery. And that's it. That's all the data we will ever get. And because it's moving away from the sun out into deep space, the chances it passes another planet are almost negligible. So no, it won't burn up. It will just be this cold lump of dust and ice forever.
Wow. So, YouTube has some excellent videos on Oumuamua, Polly said. And we know that Karen's part of that. Polly, Jason.
Yes.
Okay.
Yes, in a big way. Even though she begrudgingly became a part of the team because
it wasn't begrudging. It was declining.
What was it that made you say, fine, I'll come in? What was the selling point for you to say, I'll go into my day off?
This is the first of a kind. That's exciting.
I mean,
that is exciting.
I absolutely agree with you where you say that this is the closest to being on Star Trek. It truly is. You are discovering things that are new and foreign to us. You are bravely going to where no one has been before. This is truly uncharted territory. And one of the things that I saw on your TED Talk, there was kind of a button after your talk where they had mentioned you had mentioned that about how you meaning the collective folks working on this, caught Oumuamua on its way out, essentially, as opposed to its way in, and that something like this would be very amazing to catch on the way in, and so you guys are looking even more diligently now to the skies to see if this has happened once, there's who knows, maybe it will happen again, and maybe we'll catch it on its way in.
Oh, well, we did. In fact, in 2019, again, just before another big science meeting, a second one was discovered. And so during the meeting, everyone was not paying attention to the science meeting. They were trying to get observations. But this one, we were lucky. It was discovered on its way in. and it did not come as close to the sun. It came just inside the orbit of Mars, and we had good visibility watching it for over a year. And so now we had our last Hubble observations on this second one in March of this year, and that's it. It's too faint, ever more. So the predictions or the expectation are that there's probably one inside the orbit of Earth, closer to the sun than the Earth is at any moment. And we just can't see them because we don't usually point the telescopes towards the sun. So there's probably a lot of them in the solar system right now. And the trick will be to have a spacecraft ready and built, ready to launch towards one that we discover.
You need, hopefully it's auto drive, because I don't know if anybody would be willing to sacrifice themselves, but.
Well, you know what? I've been to science meetings where people have asked the astronomers how many would be willing to go on the first manned mission to Mars, knowing it's a one-way trip, and that you probably won't live very long because of the radiation. And I'd say 75% of the hands in the room go up.
Wow.
That is wild. It is kind of sad that it maybe in my lifetime I might not ever see the discovery of actual life out there. But I'm still living on what you said, thinking about what you said about how a piece of Mars could get knocked off and it's hit Earth and bring some bacteria there that we haven't seen. Has this actually happened? Is it a stupid question for me to ask that?
No, like I keep saying, the questions that are the most interesting are often asked by either kindergartners or people totally outside the field, because you're not afraid thinking, everyone's going to look at me like that's a stupid question. So in fact, there was a Mars meteorite discovered, I believe it was 1996. It was called Allen Hills 84001. That was its catalog number. And when the scientists looked at it, they had 4 pieces of evidence that each standing on its own didn't really say much, but when they took it all together, they said, oh my gosh, this is possible evidence of life on Mars, past life, because there were structures in the meteorite that looked like they could be similar to fossils. Some of the chemical makeup of the material was similar to what you see remnants from ancient life on Earth. And hundreds of papers were written about it. In the end, it was decided that it was not representative of life, but it opened up the field of astrobiology. And everybody was pouring money into scientific research to search for life elsewhere. So I think there's huge interest in space missions. There's a mission that will be launching, I think it's 2024, that's going to Jupiter's moon, Europa. And this is one of its big moons. It's covered in ice, but it's got an ocean beneath the surface. And that ocean very likely has hydrothermal volcanic systems on the seafloor. And whenever you've got organics, you've got energy, and you've got liquid water, you have the right ingredients for life. So I think people are really thinking, maybe we discover life in our solar system, even if it's only microbial life on Europa, or there's oceans elsewhere in the solar system. So it's exciting.
I mean, that would be so wild if they could capture some of that and bring it back. But is that safe? I mean, to bring back, or I mean, as long as you keep it contained.
I was on a committee once talking about sample return from Mars and what would be the conditions that would make sure it's safe. Now, of course, if you heat the rocks before you bring them back until they practically melt, then it's safe, but then you've lost all the information in the rocks.
Right.
You want to protect Earth from the rocks in case there's something dangerous, but you also want to protect the rocks from Earth so that you don't accidentally put Earth microbes on it and say, whoa, I've discovered something. I think it's safe. You would, of course, take precautions, but if life evolved elsewhere, most of the viruses, bacteria that we have on Earth are harmful to us because they interact with our biology so well. And if it formed elsewhere, it's not grown up to do that, but you still, of course, would be careful. So I think, yes, we know how to do it. We know how to bring materials back safely.
Yeah, I'm sure if I was thinking about it, professionals would be thinking about it too. Oh my God, I hope they realize.
Yeah, with the first Apollo samples, it was so funny. They they were worried about this, even though the scientists said nothing is going to survive on the moon. You don't need to worry about it. It's a hard vacuum. There's radiation. So at first, they thought they'd have to bring the samples back and keep them in a box in a vacuum. And that didn't work because the gloves would get so stiff because it's in a vacuum. So they gave that up. And then at the end, they were supposed to, when the first capsule landed, they were supposed to take a crane, lift it out of the ocean, put it on the deck of a ship, and have the astronauts go into quarantine. Turned out that didn't work, so they told the astronauts to vacuum off their suits and climb on out. So, and then walk across the ship into the quarantine environment. So, yeah, they did the best they could, but there were no problems from that.
That's
Wow.
good to hear.
So I real quick, because I'm seeing that we're at the 45-minute mark now, and I see that we have a couple more questions or comments from our beloved peanut gallery. So I just wanted to touch base with them. Polly Chaser wrote, I think we can all agree that some form of, well, actually, before we get into this question, you were mentioning about people being asked whether or not they would go on this one-way trip. To Mars or any of those. And Polly Chaser's comment was, me and 20 fit chicks and I am game. I don't know if that's how it works, Polly Chaser. So let's go to your question, though. I think we can all agree that some form of alien life is out there is highly likely. But do you think that some aliens have actually been able to overcome the energy requirement to get anywhere in the universe and visit this planet? And Moonlight's commenting on that said, yes, I do. My youngest tells me that he is an alien, so as a mom, I have to believe him. But what are your thoughts, Karen?
I would say no. I don't really know, but I think the things that we call UFOs, you have to investigate them as thoroughly as you would any homicide, and usually the money isn't put into them. I think real things are being seen. It's just what they are. And when you actually look at the energetics needed to get here, it almost doesn't make sense to do
I
it.
agree. That much I agree with, yes.
At least with the technology that we can envision, not that we've developed it, but that we can envision that follows the laws of physics, the energy requirements are so huge, you'd have to pretty much use all of the world's gross national product to pay for an expedition, and then what's the point of doing it? You're not going to use that kind of resources for pure science. I think if your world was in that dire of straits, you'd be colonizing other planets in your solar system, which is a much easier task. I don't know. I always get students say, but what about the physics we haven't invented? And I'll say, well, I can't comment on it very well.
Hasn't been invented yet.
Or discovered, yeah.
Or discovered.
I would love to believe so because I grew up on Star Trek, but the practical side of me says no.
Logical.
Thanks, Spock.
But you can still imagine. That's where it's fun. That's where the movies come in.
Of course. So your preference leans more towards Star Trek than Star Wars, which was many, many years ago, as Star Trek is in the future.
Yeah. Or Avatar, that was a great movie too.
I forgot about Avatar. That's right. Yes, Justin?
So actually, before we get too much farther, I've tossed this up on the screen earlier, but I would love for you, Karen, to tell us a little bit about this website that I have been sharing, the ifa.hawaii.edu, and I'm going to share it on screen. Can you tell us and the folks at home what this is?
Well, this is just our Institute for Astronomy. We're a research unit at the University of Hawaii. So this is our main website that just badly needs a facelift, and we're working on that. But on the front page are all the press releases of new discoveries. And so every few days there's something that comes up, either a new discovery that's really cool or something about awards. I haven't seen the ones for today. Bounty of oscillating red giant stars, or astronomers discover closest image exoplanet to Earth. And that was actually a graduate student project. So we've got a lot of cool stuff. And then, like if you click on the next one, the double bubble solar eruption news story, you'll see most of these come up with really nice pictures. So it's kind of fun to explore through here. Then, of course, the rest of the web page has details about our telescopes, the graduate program, and the science that goes on here.
So, folks at home, if you if you want to know more about what's going on at the University of Hawaii and what Dr. Meech is doing and her colleagues, make sure that you are heading over, and I will put it up on the screen one more time, to www.ifa.hawaii.edu. And it'll take you right there. So that way you can find out all the amazing things that are going on and what we are learning about our universe and everything around us. So I just had to do that plug real quick because I think I think was important. I kept popping it up on the screen, and I wasn't sure if anyone actually knew what the heck it was I was showing them. So I figured we should take a minute. And Moonlight's already said we'll definitely be checking it out, especially since you have some young ones that are very interested in what's going on and what's going up and what's coming down. I think you were just saying earlier, Moonlights, that your oldest cannot stop talking about Elon Musk and your little one actually not being from this planet. So yes, I think you have to make sure you bookmark.
This is a great way to get kids excited about astronomy, about a technical career eventually. And yeah, I keep saying, well, there's some downsides, bureaucracy, paperwork that you have in any job. It's a pretty cool job when you get to spend your time researching ideas and making discoveries. That's what's really fun. And Hawaii's not such a shabby place to live either.
Oh no, you're living the dream as far as we're concerned.
Folks at home, there was a possibility that Dr. Meech, she was actually just in a meeting and wasn't sure whether or not she was going to be able to be here at the start of the show. And me and Jason were just saying, yeah, I know has it so rough, slumming it. So which island of Hawaii are you on?
Well, I'm on Oahu, but our institute is across 3 islands. We have facilities on Hawaii Island where most of the telescopes are. And then we've got facilities on Maui Island where the solar telescopes are. So we're spanning 3 islands.
Wow.
So your commute is a little crazy.
Well, right now, nobody's flying too many places, but inter-island is quick.
True.
But of course, you go to meetings on the mainland and everyone complains about flying. I go, the smallest flight I take is 5 hours. What's the big deal?
Oh my God. Yeah. And Polly say what is he talking about? You would actually need to suck suns dry to get anywhere near the speed of light. Even that would not get you anywhere soon. Alpha Centauri is 4 light years away, and that is just the closest. Space is huge. This is true.
Yeah.
The Breakthrough Starshot project is trying to use private funding to send very small spacecraft to Alpha Centauri using solar radiation pressure. Whether or not they'll actually do that, I don't know, but it's a pretty neat concept to try and visit another star system.
Oh my God, that would be, it's just a matter of getting volunteers.
No. These are really tiny. I don't remember the size, but small.
Oh, you don't mean sending people over there?
No. Centimeter-sized spacecraft.
Oh,
it's
wow.
Tiny. Just to get there, I don't know all the details, but of course there's also the field of SETI, Search for Extraterrestrial Intelligence, which is both listening for radio signals to see if there's anything either intentionally sent from other star systems or accidentally leaking out, like all of our radio and TV is leaking out into space. But there's also a field of optical or laser SETI, where people use different wavelengths of light, maybe to intentionally, if there's aliens out there that are intentionally communicating, we could detect it from afar. And I know that a lot of the SETI researchers think we might know within our lifetime if there's any technological civilizations in our galaxy.
That's amazing. I didn't even realize there could be. I'm still hooked on the centimeter-sized spacecraft you could send up there.
Actually, what it is, see, she's actually messing with us. It's just a bunch of guys in a gymnasium throwing paper airplanes. No, I'm joking. I'm joking. But that's really how it's. I mean, I agree, Jason. It's amazing to think that this very, very big concept is being done on such a small scale.
Well, especially with the SETI research, it's cheap. Just listening for radio signals is cheap.
Yeah.
Oh,
That's a good point.
Got a good question here on spectroscopy. So spectroscopy is just the ability to, the light we get from things has different wavelengths or different colors. And when you see white light, it's a bunch of different colors mixed together. Now, if we can divide up that light finely, we can look at effectively the fingerprints, because different materials will reflect light at different intensities, different brightness levels. So, for example, if you had organic compounds, they don't reflect the light evenly, they'll absorb at certain wavelengths. So even if something is very far away, you don't need to be able to resolve it. It can be a speck of light, but the spectrum can tell us what its chemical makeup is, as long as it's bright enough that we get enough light. And so with Oumuamua, it was pretty faint. And so we couldn't quite do that experiment, but we could get its color, and it was red. Now that doesn't mean red like, someone's red t-shirt. It just means it reflects more red light than blue. And that's typical of organic compounds. But that doesn't mean it's made of organic, because Mars is red, as everybody has seen pictures, and that's because of the minerals. So red is not very unique, but it tells us it's what you'd expect from a comet.
It's a little bit of being able to read and study it a little closer, huh?
If we'd had a spacecraft that could have been launched to Oumuamua, that would have been fabulous.
You need to invent light speed for that Millennium Falcon, yes.
No. Actually, right after it was discovered, some scientists at JPL, along with others, worked out that there was still time to build and launch a spacecraft that could reach it. It would take a while, yeah, and it would be at about 100 Earth-Sun distances by the time it got there. And it would be an expensive mission, but not unreasonably so. It would have been about the same cost as, say, the Galileo mission, so about $1 billion. One piece of military equipment or so. So
Jeff Bezos could have done that easy.
Yeah, it's within our technology, and we could have done it, but nobody decided to do it. But they are talking about having a new model for missions where you have a spacecraft that's built and ready to launch when something new is discovered, so that you don't waste the several years to build it. It was interesting at the TED Talk. Right before the talk, I knew that Bezos was in the audience.
Was he really?
Yes, he was. And I said to the person who was I guess you call him my handler, I've forgotten the formal name. I said, "Where is he sitting?" I said, "I went out there and I looked." And he goes, "Well, he's bald." I said, "I know that, but half of the people out there are bald." And so I was nervous at this point. So he went out and he said, "Oh, he's going to be hard to see because he's sitting way off at the side of the stage." And so during my TED Talk, and I don't know if this was caught on camera or not, at the point in my talk when I said even private industry couldn't build a spacecraft this quickly, I whipped my head over to look at where I knew Bezos was sitting. Who knows if he saw that or not.
Well, you know what? We're going to clip the part of this interview where you're saying that and find a way, hook or by crook, to send it to him.
Please.
Oh my goodness! And I'm looking at the clock now, and we are at that time again. I know, Dr. Meech, you were saying that there's a ton of work on your desk that needs doing, but we cannot thank you enough for spending some of your day, some of your time with Jason and I over here on Hi, I'm Jason.
Well, this was a lot of fun, although I'm very surprised that you want astronomers on a comedy show.
Well, as you can probably tell, I felt like I couldn't keep up, but I found you so fascinating. I found all the information so interesting. and I have so much more to think about and research just for my own self satisfaction. I love it.
And I hope that you will answer our
Oh.
follow-up emails after actually being on the show. But I feel like, especially after having this conversation, there is so much more that I want to research. And who knows, maybe in a month or two, would you entertain the idea of maybe coming back on for a follow-up?
Sure.
Oh, I love it. I know
So let's make some stuff happen out there in space before you. No, just
Well, you know what? If we want to know stuff that's happening up in space, all we have to do is go over to the website over here. Let me actually pull up the correct screen here. The ifa.hawaii.edu, and again, there's news
how
and
do you pronounce
events.
that?
I'm saying
Hawaii?
Hawaii.
You're saying Hawaii.
Am I saying it incorrectly, Dr. Meech?
No, you got it. You got
Okay,
it.
there we go.
Oh,
It's
okay.
an acronym, Institute for Astronomy. And so am I going to be seeing both of you applying to our graduate program in the fall?
Oh, absolutely.
Yes, indeed.
Yes, please.
I
just
need
if you really want to laugh, yes. Look at my application. But folks, yeah, if you want to be up on the most recent news of everything above, make sure we are going to ifa.hawaii.edu. And I'll toss that up on the screen as a banner in just a second. But again, Dr. Meech, thank you so much.
Yeah, thank you. And it's just a pleasure to know that there's smarter people watching the skies for us, because God forbid we had to do it.
Well, thank you for having me.
Thank you again. It's been a pleasure.
All right.
Okay.
All right,
Talk to
take
you
care of
later.
yourself. Bye.
Bye-bye
Bye-bye.
now.